Hi, I'm Michael. In this video, I'm going to introduce Foldda, which is a software breadboard that allows easy and intuitive building of component-based software. A conventional breadboard is a tool using in electrical circuit design for fast prototyping. In a breadboard project, each component has a specific function, and when components are connected through the breadboard, collectively they will perform intended task of that project. Foldda borrows the concept and wants to achieve the same goal because in software development, making design changes are the most costly factors. In the demos in this video later, I'm going to show you how to use Foldda to achieve component-based software construction in a way very similar to using a breadboard. But before we enter into component-based software development, we need to firstly define and then implement software components. Such a subject can be very academic, but generally speaking, among the other things, we need to define and implement two things. First, the boundary of a component, so it can be separate from and be related to the other components. Second, how the components input and output are connected together so they can collaborate and interact with each other. And these two definitions need to be generic and universal regardless of a component's function. In the analogy to hardware breadboard, each electrical component would have some pins and poles that can be plugged into the board, and these pin and poles are the standard universal interfaces that allows components to be connected through each other uh, through the breadboard. Component-based development is different from some low-code and no-code GUI IDE because software developed in this IDE cannot be taken apart and reassembled without having to rebuild and recompile. Our definition of software component are swappable like a light bulb. So, the definition of software component are as following. A component is packaged as a file system folder. Each uh, each folder, when they are nested from as a child and parent, it defines the data flow from one component to the other. So in this example of the diagram, component one uh, generates the output and put into component 2 as the input. So in this case, we will configure component 1's folder underneath component 2 folder into component 1's folder as its child, which defines the data flow from component 1 to component 2. And then in program, it becomes a folder hierarchy. So if one component has many output receiver, you will have multiple folders put into component one's subfolder as a subfolder. And then finally, a runtime is a program that provides an environment to execute such a assembled program. We'll show you in a demo in next slides. Let's say you want to build a testing tool that allows you to read a file's content and sends the data inside that file into a network destination. So in the way Foldda building a program, you do the assembly of the program in such three steps. Firstly, you need to choose all the components that require for your program. So in this case, you need a module that have the ability to read the file content. And secondly, you need a module that allows you to send the data uh, to a destination, and you need to connect the two modules together so the reader will pass on the data it finds or retrieved to the network sender. So let's see. Uh, so that physically you will get a net sender module and put it underneath the file reader module. So let me show you what it means in the real in action. So now here we have blank empty directory. So we are choosing two modules. One is the file reader, one is the network sender. So the file reader is this module here. So actually we just holding down the control key, file reader and network sender. Just copy and paste. Now we just rename it. It doesn't matter what the name is, as long as the feature is the same. So we have a file reader, and then okay. So for some reason my Windows doesn't automatically refresh. So now we refresh. So we put according to the design, we put a net sender underneath the file reader like that. So that defines the data flow. So whatever read from the file reader will be passed on to net sender as the second step. Okay, now we build our program. We need to put the program into a runtime. So the runtime program is a standalone executable, which like this. So we just launch that program, and then we can deploy our program to the runtime like this. So when you do that, the runtime recognizes the folder hierarchy and recognize there was top layer. The top layer is the reader, and the second layer is the sender. So you build the data flow like that. And when you look at the input, uh, you can just get it from a destination, a source, and then output you send to, in this case, same local host by the port 1236. Okay, now to run our program to verify, we need to have a receiver program that listen to port 1236. So 1236, and we start listening. Okay, so we have a 1236 that listening to the port where this net sender is pointing at. So if we start running this program we just developed, which we assembled just now, uh, and if we start sending the files from the file reader, it will read the file to retrieve how many records in there, and then send it down to the net sender, which will get sent to a destination as we designed. So 16 messages coming through and 16 messages being sent out, and we'll see 16 records coming from here. Okay, now this is the very simple hello world uh, program we just built with two modules. But it's a useful tools for you to testing nonetheless. Uh, read some data from a file and send to a, a network destination. Now, this is our first program. We can just unload it. So ready for the second test case. So now let's say you want to extend your Hello World program so you can send the same data but to two network destinations. So in this case, all you need is put another net sender out. So you have one input but two different target or destination at the network sender. So all you need to do is to have another sender module uh, underneath being put into the file reader module. So that's how you do it. So that's very simple. So all you need to have down is to just copy the sender one and make a copy. Right, that's simple as that. And then you can all you need to do we rename it. Right, so now we have one network file reader and 2 output modules. I need to refresh it. So we have 2 modules coming out. Now, go back to our runtime. All we need to do is to deploy that program we just built. Now you have 1 reader and 2 output. Because we just copied it, the 2 actually have a same configuration. We want to rename we want to reconfigure the second module and make it to point to a different destination. So in this case, we point it to a different port, but on the same host, which is local host on the same computer. So we just save that. Okay, now that's that. So if we start this program, we'll have 1 file reader, 2 different output, right? One goes to 1236, another one goes to 1237. Now let's test this out. So this is message receiver. We clear the content. So now it's listening to port 1236 still. So we just start putting some files into that. So we're putting 16 messages across, and then for this one, it's sending 16 messages to port 1236, which is already there. So we can just check the 16 messages. But for the second one, which is sending data to 1237, is generating errors because it cannot connect to port 1237 as currently there's no one is listening on that port. So what we need to do is to stop listening to 1236 for the listener. We change it to 1237. We'll clear the record that's been received, and we start listening. Once we start listening, this sending program will discover the port that is listening, and we will start sending the 16 messages out, and then so you can see 16 messages coming across, and there's no more errors. It starts plumbing out all the 16 records on this second module. So you can just see the 16 messages also coming through to 1237. Now that's the second little modifications. Now you have a multi-destination test tool. If you have 1 file, you can send to multiple destinations. Now let's say your requirement also changed. You want to be able to send your data to multiple destinations, but for each destination, you want to be able to change the data being sent out according to the file content. So in that regards, you want to put a filter elements before they send out, so that the filter allows you to select certain data on first branch and then select the certain data on the second branch. So to do that, you have your configuration, but you need to put in between module uh, in 2 branches, and then the module will be called a filter module here. So let's go back to our design board, which is here. We have a file reader, then we have 2 sender program. Now we need to put in a filter module in between. So let's get a filter module here, copy and paste. And then we need 2 copies. So just copy and paste. Okay. And we just rename this module to be, so you have 2 filters. Now according to our design, in this diagram we put network sender under the first filter, and we need network sender 2 to the second filter. So we have the file reader at the top, then underneath we have filter 1 and filter 2. Inside filter 1 and filter 2 we have network sender 1, network sender 2. Now with such a program design, we can deploy this program Now, now, we just need to deploy this program to the runtime. So here, let's read. Now we can see the design as such: reader, filter, sender. As the runtime discovers the settings like we just configured now, right? Now, if we start, oh, we need to change the filter because we just copy, so they're having the same settings. So let's say change the first filter, we change the condition that based on the content. So we want to say only send the ADT messages. So this is filter condition, say when this actual 7 data element matching this criteria, so that this element must have the value ADT. Then we'll send out as such. And then for the second filter, we change it to say this data element, we don't want to have ADT as this value. So that means we will have different data type goes out through different branch. So in this case, ORU and ORM messages coming through the bottom branch, because the second filter only picks the ORU and ORM messages, as compared to the first filter will pick only the ADT messages. So if we start the module like now, you will see the configuration has changed. Right, so this one only listen to ADT messages, so it will get filtered ADT messages through the top branch. And if you look at the second filter, it will take the messages from ORU and ORM messages. Okay, it's already started. So if we now send the file, so let's see our listener. We clear them out. So we are already listening on the bottom branch, right? So if we start, we are already listening. If we start feeding the file, we're expecting ORU and ORM messages going down towards the second branch, which is this pool is listening, 1, 2, 3, 7, and then let's see if that happens. So we are sending 16 messages. So you can see 8 messages coming through because not all 16 messages are ORU and ORM. Actually, as a matter of fact, only 8 of them are ORU messages. See here, ORU messages, 2, and ORM messages is third one. So there's no ADT coming down from the output of the second branch, which is on port 1237 here, 1237 of that second branch. But if you look at the first branch, because as again we haven't been listening on 1236, so nothing coming through. So all we need to do is to clear this. We change this listener to listen to 1236. Then we start listening. So what will happen is that we're expecting A messages coming through, and all these messages are ADT messages because we have set up the filter of the top branch. Say I only need ADT messages coming from the top branch. Yeah, and they are ADT messages coming through the destination of port 1236. Okay, now you have a setup that allows you to send data, different data, depends on the content of the file to different destination. That's something useful if you want to maybe split the data to different destination. Okay, but let's say you want to change your setup and make it a network forwarding proxy. What does it mean is that if you have a network receiver, you can change, you can forward the data to different destination uh, and put some filtering conditions for different branch, right? So there's like a forwarding proxy. So all you need to do in this case is to changing that file reading component to a network receiver component, and this is how it's been done, like such, right? So before that happens, we just unload our module. So, and then we will swap the file reader with the net receiver. Okay, so that's easy. We just do what we just did like before. So we have test board. We want to put a network receiver, which is here. Copy, paste. Now, what we need to do is to copy the filter, two filters, into the network receiver. Actually, instead of copying, I'm going to do a cut and paste. I'm going to cut these two into the network receiver. Now, we don't need the file reader anymore because it's not in this setup. So now we have a network receiver and we have two filters underneath. In the filter we have net sender 1 and net sender 2. But let's say we want to extend our setup a bit further. We want to add, we have a network forwarding proxy being configured as such, but we want to add another feature called data archiving. So whatever data has been sent out to a destination, we want to have save a copy of the data. So we just put a file writer under filter 1. So in parallel of sender 1, we put a file writer here. So that will capture whatever data being sent out to sender 1. So we have a copy of the data, and we also being able to track what has been sent out, and we can resend the data if we want to. So we want to put a file writer module in here. So the way to do it is very simple. We just need to get a file writer module, which is here, copy and paste. We name that to file writer. Right, now we have a network proxy. We'll see that file in a minute. So we deploy this program and see what's our structure like. Deploy to the runtime again. So we have two branches again. The first branch with the network receiving, we filter it out of the ADT messages as we have done in the previous example. So all the ADT messages go out to the network sender, but at the same time, it will have a copy being saved by our file writer, and we haven't changed anything on the second branch in terms of the output, but the input is from a network input port because we have swapped the module, the input module from a file reader to a network input listener. Okay, now let's test this out. More specifically, I know this file network sender will most likely work because we know that listening is work through other experiment. So in this exercise, I want to see the file saving. So at the moment, if we look at the destination folder, there's no file in there, right? So if I start our project, no input. No, actually, I want to start the project first. And then if we start, no, because it's now not a file reader, I actually need to send the file through a network sending program. So we have a network sender which point out to the listening port 1, 2, 3, 5, which is this module is listening on 1, 2, 3, 4, 5. Now it's listening. So if I'm sending the data towards this localhost port, we'll see the file gets received and passed down into two network destination. Now 16 messages going out, uh, and of course 8 went out to one branch. If you look at the listener, we will see 16 messages going this way. And if you look at the second module, again, you'll see 16 messages going out this way, or 8 messages, because only 8 out of 16 coming from the bottom branch. But more interestingly, I want to see 8 messages of ADT has been captured in this location, which is the output directory here. So if you look at the content of this file, uh, we'll see 8 ADT messages are in this file, right? So we have a network proxy program that allows us to send data from the network to 2 different network destinations, as well as capture the data being sent out as archiving. So by looking at this project, we already built something very useful uh, as a interface. But you might or might not agree, the way we build the program is similar to a breadboard, as we do in the electrical project. Um, but I would argue that software breadboard or using software component has more advantages because software component can be duplicated without extra cost, right? We can copy and paste as many as module we like uh, in our project. Just change the configurations with no cost. We can still build a more and more sophisticated project. And component can be easily configured. We don't have to change uh, like hardware component that we can't easily change parameters, but for software that can be easily configured, like the port numbers for sending out and so on. Most importantly, you can make software component through programming, which means every time you make a new component, you will be able to combine with the other existing components together in a project. That means you have infinity variation of software application that can be built. Now, what you can do is that I want to show you the last bit is that now we have a program we built. So all I can do is to show you that the test board we just built with the network in and with all the we can just zip this up because they have just folders, so we can just zip up these programs into an archive. So I'm going to put this one as a downloadable file in the link below this video. So you can just download this and unzip, and you get the hierarchy of the module that you can test on. Uh, and you can also download the runtime from Foldda.com, so you can launch the runtime program, and you can just unzip this project file I'm going to provide, and you just drag it across to the runtime, and you have a play yourself. That's how easy you can build your program. And also, you can build your own module using the API available on GitHub. And of course, you can check out the modules and the offering at Foldda.com. So that's the end of this video demo, and I hope you enjoy it. Have a good day. Bye for now.